Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Last time we were done with the group command, right? And we just gave a hint about the pivot tables. So inshallah today we'll cover as much as we can from the three remaining commands: pivot, join, and map. At least pivot and join, inshallah, we will try to cover. So what is a pivot table? If you remember, what was the role of the group command? What is the job of grouping? So we group together the rows, okay, for that has the same value in a specific column, okay, or multiple columns. So we saw last time that we can group with multiple columns. Okay, in this case, we will group for pairs of values if we have two columns or more. And when we group, we need to specify what to do with grouping, right? By default, when we group, we count the number of rows, but you can also say, I want to do something on that column, okay? And I want to do a custom function. Okay, and that custom function can be applied to one column or the remaining columns, okay, all of the numeric remaining columns. And we saw, I think, last time an example with the averaging, right? So when we average, when we group for two columns, we get all the rows for the unique pairs, and then we average all the other columns, okay, we average the values for all other columns for the unique values. So pivot is a special case of grouping when we cross-classify. We talked about this terminology before, cross-classification, right? So here we cross-classify according to two categorical variables. So here it's a special case. Group can be applied on one column or more. We can apply it on two columns. We can apply it on three columns, right? Pivot tables, we can only apply it to two columns or two categorical variables. And it will produce a grid, like a matrix, okay, where the columns belong to one variable and the rows will belong to the other variables. So the columns, we will see, in the columns, we will see the unique values of one variable, and the rows, we will see the unique values of the other variable. Right. If that's the case, then what is inside the table? So imagine now the pivot table, rows and columns. Rows will belong to one variable, columns will belong to the other variable. Now what is inside? By default, what is inside is the count, okay, of the intersection of each row and each column. We'll see, of course, an example. And if we want to do something specific, then we should give the custom function. So we have two arguments. The first one, two required arguments. The first one, the variable that will form the column labels. The other one, the variable that will form the row labels. And two optional arguments. If we didn't give any other arguments, then we will count as the default for grouping. But if we give these two arguments, then we will say what we want to present and how. Okay? We want to present the values on a third column, and here is how we will aggregate the values. So either we give these two optional arguments, or we give none of them. The column to aggregate and the function to aggregate with. What we want to show and how we will show it. So let's go through the demo. I think that will be more clear. So we will work on the version of the survey, of the student survey. When we have these columns, I think you are familiar with that. Now, if I want to see a pivot table between sleep side and handedness, okay, so the first variable here will be the values of the columns. Okay, now we have, let's say we have back, we have stomach, we have right side, we have left side, and so on. So each unique value will be a column. And because of the second argument here, each unique value of handedness will be a row. Okay, so you would expect the number of rows to be the number of values of handedness, and number of columns is the number of sleep sides. Okay, since we didn't give any other arguments, then the cells of the table will just have the count. Okay, so here is what we will get from that. So you will see ambidextrous, okay, left-handed, right-handed. These are the different values of handedness, right? And then there is a column for each sleep side. Back, left side, right side, and stomach, and so on. Okay, what is inside here? The count. So what do we mean by this 30, for example? So we have 30 students that are left-handed and right side in sleep. Okay? Is that clear? Now we can have zeros here, of course. When can we have zeros here? Yeah, if this pair doesn't appear in the table, okay? Yeah, maybe there is no one that is right-handed and right side. Okay, if that's the case, then we'll have 0 here. Okay, if you compare that with group will not show this. Group will only show the pairs or the combinations that are observed already in the table. Okay, but the pivot table will give you the whole thing. Even the things that didn't appear, you will see zeros. Is that clear? So that's a difference. That's one of the differences between grouping and pivot tables. And of course, the big difference is that group, the table that you will get from group, you will get the unique combinations as rows, and the columns will be the values that you want to aggregate. But here, it is a table. It is like a 2D matrix where the columns belong to one variable and the rows belong to another variable. So this is visually is easier than grouping. Although grouping, you can do multiple columns. But here, multiple values, multiple variables. But here, we are just displaying the relation between two variables. Okay? Now, what will happen if we have this command, pivot, sleep side, handedness, extraversion, and average? What do you expect? What is the meaning of this? What's the difference between the table that we will get, the pivot table that we will get from here, and that one?
The values inside.
The values inside?
They won't be the count, but the average of the extraversion of the left-handed students, for example.
Yes, the extraversion of the intersection between the row and the column, okay, instead of just the count. And of course, here you can give any function that will take an array of values. Okay, what is the array of values here that we are aggregating? Amina, are you with us? Okay, what is the array of values that we are aggregating here? The extraversion. Okay, so here we will get the average of extraversion for every combination of slide side and handedness. So if we run this, then we'll get the same size of a table, by the way, because the same unique values in that variable and that variable, but the values inside the table, of course, are different. Here are just the counts, and here are the averages or the way that we aggregated the values. Okay, again, in the table, you will see just one value for each cell. For each cell, there is one value. But if you want to have average of more than the extraversion, if you want to average other columns, you cannot do it with pivot table, but you can do it with group. Right? So just reminding you of what we did before, if we do something similar with grouping, so just drop the year here, and group sleep side and handedness, which is the same like what we did here, and averaging, here you wouldn't expect just one value. It depends on the number of remaining columns other than the two that we are displaying. So you will see here that here are the two combinations of the two variables, right? So these combinations are the combinations that we have in that table here. But we don't have only the average of one column, we have the average of all the other columns. We have the average of the extraversion, number of texters, and the hours of sleep also. So for each combination here, we have 3 averages. We have 3 values. But in a pivot table, we cannot do that, of course. It has to be just one value. And that's why we have to indicate from where we will get that value and how we'll get that value, which is the averaging. Any questions about pivot tables? So do you understand the idea of a pivot table? And the differences between pivot tables and grouping? Okay. So here's a discussion question that I want you to think about now. You can work together, of course, as usual. This is the NBA players data set that I think we saw before. So what do we have here? We have names of players, position of each player, the team of each player, and the salary of each player. So each row here is a player. Okay? And we have multiple teams. Each team has, of course, multiple players in multiple positions. Usually in the basketball team has 5 positions. Okay? So, of course, you might see multiple players for the same team for the same position. So that's the data set that we have. Now, assume that, of course, I don't know if you know or not, but in basketball, we have 5 players at a time playing for the team. Okay, the others are just waiting to back them up. So maybe the roster has 12 or 15 players, but 5 are playing at a time. Okay, starters here means the 5 that will start the game. So we'll assume that the starter for a team and position is the player with the highest salary on that team in that position. So the coach of the team will choose the starting players this way. For each position, he will choose the one who has the highest salary to start the game. And as we know, we have 5 positions, so we will have 5 players. In each position, the highest salary for that position, not overall, for that position, within the team roster, of course. Okay, is that clear? Now, the question is, which NBA teams spent the most on their starters? And now we know from that the criteria of selecting the starting players, right? Now, given the starting players, which teams spent a lot or spent the most in their starting teams? In other words, we need to know the cost of the starting players for each team. If we know that, then of course we know which teams have the most expensive starting teams. Okay, is the question clear here? So think about it first. So I will give you a couple of minutes. Please discuss it together, and then we will solve it together. So how can we get this using what we studied so far? Can you discuss together, please? Yes. Of course, not only these 3. Yes, we have more data. For each team, we have many players in the 5 positions. What do you mean by the year? Of course, this whole data set is from that year. Okay, any ideas? Any ideas?
You take the highest five salaries for each team and find the average.
But what if the 5 highest salaries are all from the same position? We need the starting player, the starter player in each position. We have one for each position. We need one for each position. Okay, assume that all the positions are there. Okay, we need one for each position who has the highest salary in that position, not overall. Because if we get the 5 top from overall, from the whole team, maybe 3 of them in the same position and 2 of them. So tell me how to do it then.
We will take first the 5 positions with the 5 with the
Okay,
highest
tell me the method that we should use.
We use that group
So we need to group what?
team.
Group by team.
No, by position.
Okay, team or position or both.
Maybe first the team and position.
Can we group by both actually?
Yeah.
We can group by both. Do we need to go by both team and position or just team? What do we want to get first?
Team and position.
Yes, in the beginning, we need for each team, for each position in the team, we need to get the maximum salary, right? So we need to group first by team and position. Okay, if we group by team and position, then and we aggregate by the maximum, okay, on the salary. Okay, so we go by team and position. Okay, we don't need the player, right? We can just drop the player column. We go by team and position and aggregate on salary, and the aggregation function should be maximum. Okay, if we do that, then for each team and position we get the maximum salary. Right? Now we have, assuming that we have all the 5 positions, of course, so we will have for each team and for each team now, these are the positions and these are the highest salary. Are we done?
No.
Then what's the next? Can you raise your hand please if you want to answer? What is the next step then?
We sum the salaries for each team.
For each team.
Yeah, we sum the salaries of all the positions. And
So how do we do that? We can still use anything you want, if it's valid, of course.
But Doctor, I think on the beginning we group by the team and do summation for the salary. Because summation would be like.
If you group by team first and sum the salary, you get the salary for the whole roster. But we don't want to do that. We want to get the salaries for the starters. So we need to determine the starters first. Okay, that's why you should go by team and player, team and position. Okay, now after we get the team and position, the highest salary, then as you suggested, we want to get the sum. Okay, how can we get the sum?
We sum the column of the team.
We group by the team now. Okay, so we can drop the position. We don't need the position now. We can drop the position and group by team. Okay, and what is the aggregation function will be? Sum. Okay, over the salary. Okay, so we'll just sum the salaries. Now we will have team, for each team, the sum of the salaries of the starter players. Okay, let's see how we can do that. So here is the data set. That's the whole data set. So the first thing is to drop the player. We don't need the player. And we go by position and team. Okay. Do we need to specify which column? We cannot actually. Group doesn't specify. Group will apply this function on all remaining columns. We just have the salary remaining because we dropped the player. Right? So in this case, how many columns do you expect here? 3. Position, team, and salary, and maximum salary. Okay, so we'll get this now, position and team and maximum salary. Now we can do group over the team to sum over the salaries of the starters. Okay, so now we drop the position because we don't need it. And of course, the position is not always C. We have 137 rows here down. Okay, so we don't see all of them. So we drop the position, we group team and sum. Again, we only have one remaining column, which is the salary max. Okay, so we just sum over this column, and this is optional. We just sort just to see which of them are the top. Okay, if we do that, then we'll get this table: team, salary max, sum, and that's the cost for each team now. So we first group by team and position, and then we group by the team to get the summation. Okay, any question about this? Now there is another way of doing it using pivot table. I want you to think about it. Okay, so you will have this notebook, of course. Please do the same thing using pivot table. Okay, now we'll move forward. There is one challenge question before we move to the join. So based on the same data set, now we got the cost of each starting team, right? This is a challenge question that I will leave it to you, and that will be a bonus question in homework 2 for 5 points. So this is 5-point bonus question that you can solve towards the end of the solutions of homework 2. Okay? What do we want here? We want to generate the table of the names of the starting players. That table, the table of the names. So you have the team, and these are the 5 positions, and inside the table we want the name of the starting player in that position, for that team, for that position, which means that each row here will have the starting players of that team. Of course, based on the same criteria that we used before. Okay, so that's for a bonus of 5 points in the next homework. Now let's move on to the next operation, which is join. I think you are familiar with join from databases, right? So when we join 2 tables, what happens? And what's the requirement? We will have to have the adjoining column, right, in each table. So the need for that is that the information doesn't always exist in one table, of course. So here's an example when we have drinks, and the drinks are offered in cafes with some price, but we have another table that has the discount coupons for the drinks. Okay, now I want to join these 2 tables. When I want to join 2 tables, of course we have to have a common column, a common variable. So what is the common variable here? The cafe here is the name of the cafe, and the location here is the name of the cafe also. So we can join these 2 tables together, and when we join these 2 tables, we will get the columns from both tables, okay, based on the common values in the common variable. Okay, so here is how it is written, and then we will see the outcome of joining these tables. So when we join these 2 tables, we call join on one of them, which is drinks here. We specify the common variable, which is cafe, and then we specify the other table and the column in the other table. Okay, so that's the rows in that table. We'll match them, values of that column with the rows in that table using values in that column. And here is the outcome of the join of these 2 columns. First, look at the columns. We'll see cafe, which is the joining column here, and we don't of course see location because it's the same thing. Okay, so one of them only is indicated in the resulting table, and then we have all columns from both tables. So we'll see drink, we'll see price, and we'll see coupon from the discounts table. Now look at what are the values that we have in the resulting table. Let's look at this column, this row, latte in Nefeli. Okay, so which rows here we should join with? The second one, because it has the same cafe. Then resulting from that, we will get this row. Now look at another one, which is milk tea. So what should we match with in the second column? First row only? First and third, by the way. Okay? Because we are matching cafe. So remember, cafe here is T1. So all the rows that match T1 here will be joined. Which means that this row with these two rows will generate two rows here. So this is T1 milk tea 4, which is coming 4 with 5%, which is coming from this row, and another one with 25%, which is coming from this row. Did you get that? Okay. How about this one? Is not matched because Abe's is not actually it doesn't appear in that table. Okay, so that will not appear in the resulting table. Okay, so that's the joined column, and if you notice, it is sorted. Okay, and here are the columns from both tables. Quickly, we'll go through the demo. We'll just take less than 1 minute. So that's the first table. That's the second table. And here is the result of joining. That's the same command that we saw before on the slides, and we'll get the same table. Now the question that we will start with in our next lecture is the following. Given that we have these two tables, we want to generate the table with a discounted price for each drink. So you see that table? We have the discount, right? Discount coupons for some of the cafes. We want to generate a table where, of course, this is missing. This is an error. Okay, we should have a value here. But we know we want to generate that table so that we have for each drink, we have the discounted price. Okay, and that's what we will start with, inshallah, next time. Any questions? So we are very close to finish session 3 from the functions from this session, session C from session 6, okay, or part C from session 6. Inshallah, we will finish it very early next time, and then we'll move on to the next session. Any questions? Thank you.